percent of change, that is what we are covering for today. With percent of change, our learning target is going to be that I can identify our percent of increase and decrease from real world situations. So what this means is that you have values that you start with and values that you end with that are either increasing or decreasing by a percentage amount of the original. So when we talk about things like something went on sale, the sale that occurred is a percent of change. It's a percent that you are doing that will decrease a value. When you go shopping and you buy an item from a store, that item originally had to go through a percent of change called a markup. So the markup is considered a percent of change. If I make an item and then I sell it to Target and then Target sells it to you, Target's going to mark up the price that I sold it for so that they can make a profit. It's how that they earn a living there. They make profits off of what other people are making and selling to them. They then sell it at a higher price. So that is a percent of increase. So we're going to be looking at situations, because it's not always just money that we're talking about. When we look at how your grades have changed, this is how we notice whether certain programs are working. So programs like mentor programs or programs for tutoring or programs like the Character Strong that we do or the PBIS points that we do. We try to identify whether they're working or not by looking at what original data was and then looking at what the new data is and seeing if there was a percent of change that occurred, a significant or insignificant percent of change. Okay, so those are all things that we can look at. When we talk about percent of increase, that means that there was a positive change that occurred. So that increases from original to your newest value. There is an increase there. You guys need to move down too. So percent increase means that from the original to the new, the change was positive. A percent decrease means that when you go from original to new, the change was a negative change. It means it went down. So like when we talked about price, or if we're talking about maybe your bad behavior choices, maybe those would go down due to certain things. Or maybe your test grades go up because you studied more. Those would be percent of increase. Okay? So percent of change can be found doing the following. You take what we call our newest value. So I'm going to highlight new in pink. And then you're going to subtract that with your original value. Then you're going to take that difference and you're going to divide it by your original value. And then you will multiply the following result by 100. Why do you think I say you have to multiply by 100 for a percent of change? Adonai? Because a percentage is out of a 100. So when we're working this information out, we're going to get a decimal value. We need to convert that decimal value into a percent. You can change a decimal into a percent by just multiplying it by 100. That makes it a percentage. Okay? So always going to be new minus the original, divide it by the original, and multiply by 100. So honestly, the most difficult part of this process for some students is identifying which value is an original and which value is a new. So you need to make sure you're reading carefully for key words that would indicate that this was an old value and this is a newer value. So if you need to understand original, also could be the key word old. Okay? If you don't know that original means old, that's what it means. Okay? So I need to identify what the original value is in the problem. I also need to identify what the newer value is in the problem. So when I'm looking at this situation here, in 1970, the average cost of gas was $1.30. In 2023, the average cost of gas is $2.95. I want to know, what is the percent of change to the nearest whole percent. That's another piece of information that's important because that's a rounding piece of information. We'll get to that in a second. Let's first identify which one of those values represents the original and which one of the values represents the new. So we're talking about the price change, how the price is changing. So $1.30, is $1.30 an old price or a new price? An old. Right? It took place in 1970. That's old. So $1.30 is going to represent our original. That means that the $2.95, that represents the newer price. So now all I have to do is set it up inside of my equation, my little setup here, where I'm going to take whatever my newest value is. I'm going to subtract my old value. I'll just use the word old instead of original so I don't have to write too much. Then I'm going to divide that answer by my old value. And then I'm going to multiply that by 100. So when I'm setting this up, I'm taking $2.95 and I'm subtracting $1.30. Then I'm going to divide by $1.30. And then I'm going to put times 100. Notice that the times 100 is not a part of the fraction. It's outside of the fraction. So when I work that out, the nice thing about y'all's calculators is it will do the order of operations for you. You do not need to worry about doing parentheses first and then division and then multiplication. You can type it exactly as you see it into your calculator, meaning you also need to type those parentheses. So I'm going to make a fraction, and at the top of my fraction, I'm going to put 2.95 minus 1.30. Then I'm going to close my parentheses. I'm going to use my down arrow to move down to the bottom of my fraction, and I'm going to put $1.30 at the bottom. I'm going to use my arrows to get out of the fraction because I need to be out of the fraction, and I'm going to put times 100. Okay? Everything that I have here is now replicated inside here, and I can hit enter. There's my answer. I get 126.9230 and so on and so forth. And that's okay. Remember we talked about yesterday that you can have a percentage higher than 100%. Just means that it more than doubled in this price. Okay? So when we're working that out, I'm going to put it equals 126.923, and it's going to keep going on. So I'm going to put little dot, dot, dot right behind it. Now notice that in the question it says it wants to have it to the nearest what? Nearest whole percent. Nearest whole percent. So my whole percent, here's where my whole is. Let me zoom in so you can see it better in the back. When we're talking about a whole number, my whole number starts at the 1 spot. I need to look at the number after it, the number that comes after it, to see if I need to round. So the number after it is a 9. The 9's going to tell me whether I keep the 6 or round it up to a 7. Am I going to keep it as a 6 or round it up to a 7? Round it up. We're going to round it up. If you forgot your rounding rules, if it's 4, if the number is a 4 or below, meaning smaller, that would be a 0, 1, 2, 3, or 4. You leave it alone, right? 4 or below, you just let it go. You don't do anything. 5 or above, you give it a shove. You shove it up. It's the little rhyme rule. 4 or below, you let it go. 5 or above, you give it a shove. Okay? So that 9 is telling us we're going to round this to 127 instead. Do you have a question? Calculator's in the back. Okay, so we're going to estimate this at 127. Now, this answer is wrong because I'm forgetting something. What do you think that I'm forgetting to put as part of my answer? What do you think, Brian? A percent. You need to put a percent sign. A percent sign is just as important because I'm not talking about just 127. I'm talking about 127%. You need to make sure you include your little percent sign as part of your answer. Now, I also need to indicate whether this was an increase or a decrease. So when we're looking at our original to our new, did we increase or did we decrease? We increased. I also know we increased because when I subtracted and did all this work, I got a positive answer. If I got a positive answer, it meant it was an increase. If I get a negative answer, then that would be a decrease. So I'm going to put down here that this was increase. It was 127% increase. You want to make sure that you include both. All right, let's take a look at problem number 2. For problem number 2, again, we need to identify our old value and our new value. So let's read through the problem. James bought a DVD player for $280. Now it's on sale for $220. We want to find the percent of change to the nearest tenth. Which one of those numbers up here is going to represent our old value? Aeon. 280. So that means that the new value, the new price, what it's on sale for right now, that is the 220. That is going to be our new value. Okay? So now we just plug it into our problem. In parentheses, we're going to subtract the two values. So we're going to do new minus old. Remember, it's always new minus old. So we're going to do 220 minus 280. Then we're going to divide by old. So we're going to divide by 280. And then we're going to multiply by 100. Guadalupe, make sure you're copying. Okay, so 220 minus 280. Then we're going to divide that by 280 and times it by 100. Go ahead and take a moment, put that into your calculator yourselves. Don't say anything out loud, but I want you to put that into the calculator so that you can get used to typing it yourself. Calculator's right there. Okay, now if you get a fraction as your answer, you know you can convert that to a decimal, right? You can hit the conversion button and that will convert it to your decimal for you. What did you wind up getting when you do 220 divided by the 200 and, or subtracting 280 and then dividing by 280 and multiplied by 100? What'd you get? Negative 21 point, and it just is going to keep going, right? It's going to be a long drawn out answer. When we work this out, it's going to come out to a negative 21.428, and it just keeps going on and on and on. Now, in the question, what did it tell me to round to? To the nearest tenth. We got to round to the nearest tenth. So which one of these numbers up here represents my 10th place value? Angel? The 4. The 4 represents my 10th place value. So again, we're going to look at the number after it. We're going to look at this 2 that belongs after it. So that 2 is going to tell me to keep or shove it up. We're going to keep, right? We're going to keep the 4 as it is. So our answer is a negative 21.4. Now it was a negative, so what does that mean? Increase or decrease? Decrease. Negative is decrease. So we're going to put negative 21.4% and then decrease. You just got to remember your order of subtraction. You know, what belongs where, which one's going to go on the bottom value. The old is always going to be what you're dividing by. Okay? Let's try number 3. We want the markup rate. So we're looking at an original to a marked up cost. So what the markup cost was. We want to know what was the rate of the markup. Okay, so that means which one of these is the new? The marked up cost, right? The markup cost is going to be our new. And then obviously the original cost is our old. So we don't have anything here to look at, but we do have this first column that we can look at. So we can look at the $30 in comparison with the $37.20. So we're going to plug it in into our little formula. We're going to do $37.20. We're going to subtract the $30. Then we're going to divide that answer by the old, which was the $30. And then we're going to multiply it by 100. Go ahead and do that in your calculator right now. Do 37.20 minus the 37, or I'm sorry, minus the 30, divide it by the 30, and then multiply it by 100. What do you get? 24, good. So it's 24%, and it was positive, so that means it was an increase, which makes sense, right? A markup needs to be an increase. So now they want to know, what is the markup price for a $25 item? I'm going to show you guys a nice little trick called a proportion. You're going to be using it a lot for the next couple of units, having a proportion set up. So with a proportion, what we're going to do is we're going to set these up as fractions set equal to each other. So I'm going to set this up as 30 over 25. And I'm going to put it equal to 37.20 over x. So I've created two fractions that are equal to each other. And I'm going to use something called a cross product. So what a cross product means is that we're going to multiply our diagonals together and create an equation. So I'm going to multiply 30 times the x, and 30 times x gives me 30x. And then I'm going to multiply 25 times 37.20, and that's going to give me 930. When I multiply those together. And I just set them equal to each other. I've now created a one-step equation that I can solve. What inverse operation can I do? What opposite operation can I do to get x by itself, Natalia? Division. We can go ahead and divide both sides here by 30, and we'll get that x is going to equal 31. So that would be our marked up cost from an original 25. Huh? I know. I'm aware. Thank you. Okay.